Alright, so we are now on week 8 to 9 topics. The first topic there, which is indicated in your course syllabus, is the what we call the integration technique, another integration technique, which is um, the integration by trigonometric substitution. So guys, whatever the lecture is during for this specific week, for the specific weeks, those are some techniques that you only need to do during your quizzes or exams. No, they have different outcomes. Okay, so just like on your second exam, I noticed you have used algebraic substitution, but that scope is on your third exam, not in your second exam. Okay, so I hope you consider that as well, na me being strict on your solution. So I apologize for that one. Okay, now let's have trigonometric substitution. It's another integration technique, no, to solve some problems. So first case is if you see an integrand, or if the integrand contains this a squared minus x squared, then you let x as a sine theta. Okay. For case 2, if you see a squared plus x squared, then that would be letting x as a tan theta. So a here is constant. Okay, a here are constants. And if the integrand contains the combination x squared minus a squared, then you let x as a secant theta. Let's say, for example, we have for case 1, okay, dx over square root of x squared times x squared square root of a squared minus x squared. So you see, no, the integrand contains the combination a squared minus x squared. Therefore, you are going to let x as a sine theta. Okay, so letting x as a sine theta. Okay, so now what is your dx? Remember that the derivative of sine theta is cosine theta. Therefore, your dx is a cosine theta d theta. Okay, so we have to simplify the given, no, in the integrand, inside the integrand. So you have dx as a cosine theta d theta. Your x squared, you are going to square this one, so that would be a squared sine squared theta, and this one a squared minus x squared. So let's further simplify, no. So see, a squared minus x squared, that would be the square root of a squared minus a, look, no, so your x is a sine theta, therefore x squared that now is a squared sine squared theta. So we are going to simply substitute that one into this one. So that's a squared sine squared theta. Okay, to simplify, you have a squared, times 1 minus sine squared theta. Okay, what is the square root of a squared? That is a, right? And 1 minus sine squared theta is equivalent to cosine squared theta. Remember the Pythagorean theorem? That's sine squared theta plus cos squared theta is equal to 1. So 1 minus sine squared theta is equal to cos squared theta. So by using that trigonometric identity, we have a square root of cos squared theta, which is cosine theta. Okay, then we are going to substitute the values inside the integrand, in which dx is a cos theta d theta all over your x squared, which is a squared sine squared theta, and your a squared minus x squared, the square root of a squared minus x squared is a cos theta. Wow. So look at our look at the values inside the integrand, no? It will be much simpler now because we can cancel both a cos theta and a cos theta. Now since a squared is a constant, now we can take it outside the integrand sign. So 1 over a squared, the integral of d theta over sine squared theta. So 1 over sine squared theta, that is equivalent to cosecant squared theta, tama? 1 over sine is cosecant. So therefore, this is cosecant squared theta d theta. Okay, to further understand, that's 1 over a squared, 1 over sine squared theta d theta. Again, 1 over sine is cosecant squared. Then, what is the integral of cosecant squared theta? So that is negative cot theta. Okay, so therefore we have negative 1 over a squared cot theta plus c. Now, is this your final answer? Not yet. So remember that our original values inside our integrand is in terms of x. Therefore, this is not yet the correct answer since this is in terms of theta. Now, how do we do that? So let's draw a triangle, a right triangle to be precise. Okay, so you have x is equal to a sine theta. So therefore, from x is equal to a sine theta, you have sine theta is equal to x over a. So remember SOHCAHTOA, no? SOHCAHTOA, that's opposite over hypotenuse. So the opposite side of theta is x, and the hypotenuse is a. Therefore, this value here, diba, c squared is equal to a squared minus b squared. So you have c squared, you have b squared here, or whatever the value that is. So that is c squared is equal to the square root of, the square root of a squared minus x squared. Okay? So again, hypotenuse minus this, then square root. This is the value of the other side. So now, we have cot theta. What's cot theta? Diba? Remember SOHCAHTOA once again. SOHCAHTOA. So tan is opposite over adjacent, while cot is adjacent over uh, over opposite. Okay, so AO. Therefore, that is 1 over a squared. Okay, so kabaliktaran ng uh, cot is tan. So this is adjacent over opposite. Therefore, what is the adjacent of theta? That is the square root of a squared minus x squared all over uh, opposite, which is x plus c. Okay, so now, para mas simplify ang answer, you can have the negative square root of a squared minus x squared over uh, x, or a squared x plus c. Now this is your final answer. All right, so that is for case number 1. Okay, so it's an integration technique once again called trigonometric substitution. Now let's move with the other examples. For case 2, you can see that that's a squared plus x squared. So obviously, that is a tan theta. Okay, so x, since this is in terms of x, let us use it in terms of x as well. So x is equal to a tan theta, but we have a here as 3, right? So that's 3 tan theta. Okay? Guys, pag 9 siya, then you have to, for example, the given value here is 9. Remember that this is a squared plus x squared. So you have to square it first before you use the value 9. So the square root of 9 is 3. Okay? So therefore, what is dx if x is 3 tan theta? So the derivative of tan theta is secant squared theta, right? So therefore, this is 3 secant squared theta d theta. Okay? So we have to simplify this one as well. This 9 plus x squared 3 halves. So to simplify that one, that would be 9 plus, what is the value of your x squared? That is 3 squared tan squared theta. Therefore, that is 9 tan squared theta. That is raised to 3 over 2. Okay, now let's simplify. That's 9 times 1 plus tan squared theta raised to 3 halves. Okay, we have another identity here. 1 plus tan squared theta is equivalent to secant squared theta. So 9 raised to 3 halves, that is 27, okay, times secant squared theta raised to 3 halves. So that is 2 times 3, 6 over 2, that is 27 secant cubed theta na lang. Alright, so therefore, we are going to change the values inside the integrand in terms of x. So that would be your dx, which is 3 secant squared theta d theta all over your 9 plus x squared 3 halves. We already substituted or simplified that one. The value is 27 secant cubed theta. Alright, so this would be cancelled, and what's left here sa ilalom or underneath or in the denominator is 1. So 3 over 27, that is 1/3. Again, what's left is 1 over secant theta d theta. And 1 over secant is cos, correct? So 1 over 3 or 1/3 cos theta d theta. Therefore, we can now easily find the answer. So that's 1/3, and the integral of cosine theta is positive sine theta. Tama? Okay. Oh, this should be 1 over 9. Sorry. So 3 over 27 is 1 over 9. Alright. And then, that is sine theta. Do not forget the constant. Alright. So, sine theta. This is not yet the final answer because this is in terms of theta. Again, let's draw a triangle. Okay, so in the triangle, in the given, we have x is equal to 3 tan theta. Therefore, tan theta is equal to x over 3. So, TOA. So, that's opposite. So, opposite value is x. Adjacent value is 3. Okay, therefore, the missing side is the hypotenuse, in which the formula is c squared is equal to a squared plus b squared. So that's simply the square root of x squared plus 3 squared, which is 9. Okay, so what is the value of sine theta? That's opposite. So that's x over hypotenuse, which is the square root of x squared plus 9 plus c. Alright, so para mas maganda yung answer, tignan. So that would be x all over 9 square root of x squared plus 9 plus c. Alright, now this is our final answer. Okay, perfect. Next, this case here, actually there are a lot of simpler, mas simple na problems to solve, but I want this challenging one para so that medyo we can understand more, no? um, more on the trigonometric substitution. Okay, so for this one, we can see here x plus x. Okay, so by looking again at the cases, there is no such thing as x squared plus x. But if we use algebra, no, for simplification of this function inside the integrand, so therefore we have dx over, what should we do? No? So our target here is to make an equation similar to this one, attacking one of the cases here in our trigonometric substitution. So with this equation x squared plus 2x, we can simplify it with, okay, x plus 1 squared minus 1. Look, x squared plus 1, that's x squared plus 2x plus 1 minus 1. This and this are the same. Therefore, if you are going to look at once again at case 3, that is x squared minus a squared. So we have a as 1 and x squared as x plus 1. Okay, so guys, this one we are going to let u here para mas uh, para mas dali, no, to make it simpler for us to integrate. Let u as x plus 1, du is equal to dx. Okay, so dx and x, no, very simple na lang. So that is du over square root of u squared minus 1. So if you look again at the cases here, no, u squared minus 1, so mas kanong na niya, right? So x squared there represents u here, u squared. So no, it doesn't matter what variable is we are going to use as long as our answer is correct and we understand the theory. Biskan pag B or C or D, that there's no problem with that. Okay, so let u is equal to a secant theta. What is our a? 1, right? So that is 1. So therefore 1 sec theta. So our u is only sec theta. No? Not complicated. So du is equal to secant theta, oops, d theta. Alright. Therefore, okay, let's simplify this one first. U squared minus 1. So u squared is secant squared theta. No, square ni mo siya, that would be secant squared theta minus 1. So remember the identity secant squared theta minus 1, that is tan squared theta. Okay? So therefore, that is tan squared theta. Then the square root of tan squared theta is tan theta. Alright. So that would be du, which is secant theta, d theta all over tan theta. Oops. I forgot du should have tan theta d theta. Sorry. So therefore, this should be secant theta tan theta d theta all over tan theta. Okay, once again, this is sec theta tan theta because the derivative of secant is secant theta tan theta. Therefore, we can cancel. So what's left would be secant theta d theta. And what is the integral of secant theta? That is ln of sec theta plus tan theta plus c. Okay, so this is not yet our final answer once again, no, because it is in terms of sec theta. But we have given here sec theta is, so sec theta is equal to u over 1, no? So if we draw a triangle, so sec theta is, okay, kabaliktaran siya sa cos. So, hypotenuse. So, our hypotenuse is u and our adjacent is 1. Therefore, this would be square root of u squared minus 1 squared, or u squared minus 1. Okay? So, please remember SOHCAHTOA, or the SOHCAHTOA sign. Okay? Sa patawagan na. Therefore, we have ln of the second theta is just basically u, no? Plus, the tan theta is opposite, which is the square root of u squared minus 1 over adjacent, which is 1, or simply u square root of u squared minus 1 plus c. Okay, this is in terms of u, but our original equation is in terms of x. So change u back to x. So u here is x plus 1. Therefore, you will have ln of x plus 1 plus the square root of x plus 1 squared minus 1 plus c. This is our final answer. Alright, so if you have any questions, feel free to message me on Blackboard, or I'm going to be posting a forum. You can ask questions there. Okay, so if it's very important, once again, you can message me in my email or on my Blackboard account. Thank you so much and have a very good day.